This presentation is about C# OOP. OOP standing for Object-Oriented Programming, and it is meant for COP 4020. Right now it's spring 2020, and I'm going to talk about object-oriented principles with regards to C#. So there are advantages to OOP over functional programming, I guess I shouldn't have said functional because you guys know that's Haskell. Procedural programming, which is like C and C++ and so forth. There are advantages. My biggest advantage is it's a better way to organize. One time I was teaching a night class, and these were all seasoned RPG and I guess they were all RPG and Fortran programmers. I mean, they were working at like banks and Syngenta and data masters and stuff like that, and they couldn't understand why object-oriented programming had an advantage over procedural programming. They kept saying, well, I can write functions, it's the same thing, right? It really isn't. OOP is a totally different paradigm that really is much better. Now, I still do write occasionally procedural programs, and as you know from Haskell, functional programs too. Some people say that OOP is faster and easier to execute. Okay, so that's kind of debatable. It really depends. If you're really good at thinking in terms of OOP, yes, it is. But when you're first learning OOP, it takes a while to figure out how to make things work. And hopefully, in this lecture, we can talk about some of those things and get you more up to speed. It reduces redundancy because you have these reusable classes that are meant to be reused. And I think reusability is a really big thing about OOP. Okay, so let's talk about classes and objects. Classes are really, I'll say, templates comprised of code and data. Okay. Instantiations are, I'll say, objects are instances of classes. Okay. So suppose you have some sort of a class, my class. You have stuff here, maybe a couple of methods. Boy, Notepad is a really great editor, isn't it? Okay. And maybe you have some fields up here, int, age, height, weight, so forth. Okay. So normally we call these fields, or they could be called properties, and we'll get into that later on in this lecture. So that's a class. Now an instance would be my class MC equals new my class. So that's an instance where you actually instantiate of one of those classes. You can actually instantiate it multiple times. I'm going to have the name MC2 equals new my class. So thus illustrating perfectly that idea of reusability. So just for the sake of clarity, I'll refer to this as a class, and I'll refer to this either as an object or an instance. I use those many times interchangeably. Okay, so here I've got a console application spun up, and what I'm going to do is add a class to it. And here in my Solution Explorer, over on the right side, in order to add a class, I'm just saying add, and it's got a class in here, so I'm going to make it into a car. So we're going to add a car class. And I know that I went through this in the last lecture, but we're going to go through it again and I'm going to be a little more specific about things. So this idea of a namespace, that's more an application level thing. What that does is if you have classes all in the same namespace, then it's kind of like having a variable, sort of a local variable or whatever. It lets you, without being fully qualified, it lets you access them. Otherwise, you'd have to have some sort of fully qualified thing, such as a blah 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 dot blah 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 dot whatever. This is a fully qualified namespace, so that I have access to everything within that namespace. So anyway, I really, in this course, I don't talk about namespaces too much. It's probably enough. Okay, so car. Now, one of the things I wanted to mention for object-oriented programming is methods should sound like verbs. That's like things you do, right? Fields or variables should sound like well, attributes. So I'll give you an example. I know this is a car class, but let me give you an example using a dog. Let's say this class was the dog class. Your methods might be bark, eat, run, sleep. Those are verbs. Your fields might be color, age, things that are attributes about whatever it is you're talking about. So for a car, we can still do kind of the same thing. We just have the color, we can have the year, we can have the make, we can have a model. That's enough for right now. And the methods would be so drive, start your car, so forth. Say honk, things that the car does. So notice that these are all verbs. And if you get into thinking about this early on, it will make your class creation so much easier, better, and more robust. So remember, think of fields as attributes. Think of methods as verbs. So you can have an optional constructor for car. I'm just going to put one here. And remember, the constructors are not going to return any values. So you might say your constructor might be color. You just want to set a color. So you say this dot color, this color. And this modifier means we're talking about this instance. Okay, if it's a static variable, then that's a totally different story. So you can actually overload this if you want. Year, year equals year. So let me go ahead and give these some default values. Actually, I'm going to make the color. I'm going to make the color a string and default it to blue. I'm going to have to change my methods up here. My constructors, string for the color. String the color. Okay. So, and you may or may not even call these constructors if you don't mind just having the default value. That's fine. Let me go ahead and give these default values here. Equals 2020. What a glorious year. I guess make and model should also be strings too. And let's make the make a so Nissan, Versa, oops, typo there. Okay. So that's kind of the really gentle introduction. And going back to program to instantiate this, I just say car, car equals new car. Everything's case sensitive, so that works. I've got to say red, so I've got to use one of the constructors that we created. If you don't have a constructor in your class, then there's a default constructor that it uses. But when you add these constructors, it's going to expect you to use one of them. Okay, now let's go ahead and fill in some of this methods. Say console right line. We are going fast. Start console right line. Zoom. Say vroom. Okay, and honk. That's an easy one. Honk, honk, honk. Okay. So we've got some fields, we've got some methods, and now we can go back and use this here. Say car.honk. Run this. Oops, not. So it's not liking that, and the reason is because these needed to be public. Oops. Without them being public, you can't call them from outside. By default, everything's going to be private. Those are all going to be private. Okay, so now you've got your first look at a class and an instance. Just to clarify, a lot of times we refer to these as class members. I've been referring to them as fields, which I'm comfortable with. Fields or members or even variables. Variables is probably the least common way to refer to them, but either way it's fine. I'm not going to be picky about that. Notice that these are private. You can actually make them public, but it's not recommended. The reason it's not recommended is because you don't want to give people the ability to access these unless you're going through some sort of special accessor code. You want to preserve this idea of data encapsulation. Okay, so you don't want the outside world to adjust your variables. Now there is a way you can actually give the outside world a way to adjust those variables, but the recommended way to do it is through a property. So let's create a property called year. And in Java, you had getters and setters to do this, but in C#, you have true properties. So return the year, set year equals value. There's an implicit thing called value. And now the way you're going to use that, you can just say car.year equals 2019, just like that. Okay, and that's actually, to me, a lot nicer than using the Java getters and setters. You'll also notice that it's legal to not have that, to only have a set. So then it's write only and not read only. It's legal to have a get and not a set. So there it's read only, or you can have them both. This is also legal, but it's not. Would be no point in it. Okay, so that's C# properties. So I just wanted to be clear about the access modifiers. You've already seen me put a public on those methods so that they can be accessed from outside of the class. By default, everything's going to be private. So let me just sort of go through. There are three. There are actually four, but three major accessor decorators you can use. So public. This code is accessible for all classes. Private, which is probably the most common for the class members. The code is only accessible within the same class. And protected, the code is accessible within the same class or in a class that is inherited from that class. Okay, so I actually, in my own development, it's very rare that I actually am able to. It's very rare that I've ever used protected. There is one called internal, which I'm just going to mention here for sake of completeness for C#, but we're not going to use it. And I'm not going to address it in this course. And I do want to mention that there are things in C# called automatic properties. I know here this property, I wrote my own getter and setter. But let's say you have some sort of a string. You want to say public string name. So that's actually a property. Okay, and this isn't a rule, but I put my properties in capital letters just so I know the difference. And if you want, you can have get, set, and then you don't have to do any of this internal code. You would definitely want to do the internal code if you had to, check for validity and stuff like that. But if all you are providing is some sort of a getter setter for your property, this is all you need to do. So now we're going to talk about inheritance. And to do that, I'm going to create another class named vehicle. Class. Okay. So here's my vehicle class. And I'm going to go ahead and give it a type. We'll default it to car. And I'll give car a, let's go ahead and give car a property accessor. So we'll say public int type get. Oops. Set type value. Okay. Oops, this should have been a string. Sorry about that. That's why it was complaining. And now let's go ahead and create a single method, public void show type. So right line, my type is plus type. Okay, so this is our base class, pretty simple class. But the reason we use inheritance is because we can have this vehicle class that has all sorts of things, and then we can inherit it from, say, a car class, a plane class, a boat class, and not have to rewrite a bunch of other code. So this is the base class, what's known as the base class. And car, we're going to go ahead and have it inherit from vehicle. And so this is going to be called the derived class. Okay, so now everything that's in vehicle gets inherited by car. So I can come back here and I could say car.say type. Notice it say show type. Show type belongs to vehicle, but because car inherited from vehicle, it now has it. So I can do this. Everything is cool. My type is car. Now I should say that other languages have something that's known as multiple inheritance. So multiple inheritance would mean car could inherit from multiple classes. So maybe vehicle. I don't have any other classes, but let's say I had so product, say item or whatever. Okay. So some languages will let you inherit from multiple classes. C# does not allow multiple inheritance. It was found that multiple inheritance a lot of times offered or provided more problems than it solved. So the creators of the C# language decided not to allow multiple inheritance. And one last thing about inheritance, you can actually make vehicle a sealed class. And if you make it a sealed class, then it will not allow inheritance from that, okay? So that sealed word means you're not going to allow any other class to inherit from this. So if I get rid of that sealed class, vehicle should turn back to a nice color. Hasn't picked up yet. Anyway, but this is okay. So the next thing we need to talk about is polymorphism. And here I have this honk method, which we've already used. But you can create other versions of it. Honk, say int number for int I equals 0, I less than number, I equals plus. And so now we have two of the same method names. However, they will have different signatures. This has no parameters. This has one parameter. And so this is the classic polymorphism. So I could say honk there. Tighten this up a little bit. And here I'll say car.honk 10. And that way it honks the horn 10 times. Here it calls the one overload, and here it calls the other one. So that's really a short explanation of polymorphism. So you'll hear the term abstraction quite a bit in OOP circles. Data abstraction is the process of hiding certain details and showing only essential information to the user. Okay, you can either use abstract classes or you can use interfaces. Okay, I use interfaces more than I use abstract classes just because that's a preference of mine. An abstract class is a restricted class that cannot be used to create objects. For instance, you can't instantiate an abstract class. An abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the derived class. So basically what you're doing is you're providing a sort of a contract. So what good are these abstract classes and interfaces if they're not giving you any code? It's because when you implement an interface or an abstract class, it's a contract. They tell you what methods and what fields you must implement yourself when you implement these abstractions. Let's go through and do an example here. Okay, so what we're going to do is create a special type of class. So we're going to add class, we say thing, and instead of a class, we want this to be an interface. one of the things, I probably should have named it starting with an I. Normally the convention, it's not right or wrong, but the convention is to name an interface with a capital I to start with. Okay, so now I have a special type of class known as an interface. So string, color, let me stick with my, it's going to be automatic. So we're going to have a method called open. Notice there's no code to it. No code to any of these things. Okay, so what we've done is we've created this interface, and now we're going to create a class that actually uses it. I should also mention that the interfaces do not have accessor, don't have access modifiers. So make sure you leave off the access modifiers. Okay, now let me go ahead and create another class that's going to implement this interface. So add class called item. This is a normal class. So in order to implement that interface, I'm just going to do it just like I did. Okay. And now if I try to compile this, this will give me a big error because I don't have, I haven't, right, so this interface is like this I thing, it's like a contract. If I implement this, these are the methods I have to go ahead and implement in my class. So here's item, let me go ahead and paste those in. Now, I can't just have the blank methods, I actually have to have some code in them. So let's say console, write line, test. These are showing red because there's no return value, so let's just return true. Return true up here. Okay, so an interface, when you implement an interface, basically what you're doing is you're implementing someone's idea of a group of methods that you will need. A lot of times interfaces have a lot to do with user interface. Like for instance, let's say that your user interface, it's always going to have a sort of a show or a close or whatever. It's hard to explain. I have an example I'm going to show you though. Let me make sure that this compiles. Okay, hold on a second. Okay, it doesn't like it. These need to be public. So now I actually am going to need to make these public. Okay, here. So I need to implement color. So let's go and put that in here. And then I'll have to make public also. Okay, so I think we're okay. Now we're okay. All right, so everything compiles. So let me go ahead and grab that example I want to show you in just a minute. So as an example, I'm going to use a program I wrote about 3 years ago. I was doing a contract for a group, and they needed to be able to. It's kind of a long story. I'll make it really short. We had to create PDF templates, and what we did was we were doing dynamic PDF generation, and we had to give people who didn't know any programming the ability to change the style and how everything was laid out. So I created this, and here I have a little toolbar up at the top with a bunch of item types. So here's a rectangle. So I put this rectangle in here. Notice I can move it around. I can resize it. Same for a circle. It's really an ellipse. Resize it, whatever. So what you'll notice is that a lot of these objects, they have common things that they do. They move. They're resizable. You can change the color. They both have color, inner and outer color specifications. So what we want to do is make sure that all of these objects implement the same things, so that my code, my main controlling code, doesn't have to think about, oh, well, this is a line, let me do it this way. Oh, this is a rectangle, let me do it this way. Basically, all it does is it makes the same move call and the same set color call and all this. All of these objects have the same types of things that they do. Now, obviously, moving an ellipse is different than moving and sizing a rectangle. They're different. They do things differently. So the ellipse call, it knows how to draw itself. It knows how to move itself. The rectangle knows how to draw itself, how to move itself, and so forth, how to manage its colors and all that kind of stuff. So they all have to have this common core of functions that the outside can call consistently. So here I have an interface. These are called report objects, so I call this iReport object. So every single one of these objects has to support everything within here. Here I have my methods. Those are my positional methods, my Z, the Z aspect, colors, font size, and so forth. So they're all required to implement these. Draw, is clicked, what do you do if it's clicked, what do you do when you move the object, and so forth. So then let's go ahead and take a look at one of the objects. Let's say rectangle. Okay, here's my rectangle class, and it implements this iReport object interface. And notice it's got a lot of these its own things, but it's required to go ahead and implement these coordinates. Okay, and it implements them because it must. Since it implements that interface, it must do these. Okay. Okay, and now we should get to the required methods. Draw is a required method. Okay. Notice though, the rectangle is going to draw differently than the line draws. It's going to, all of them draw differently. So the interface doesn't know how to draw anything. But each object, each rectangle, circle, or ellipse, image, whatever, knows how to draw itself, knows how to move itself. Okay. So that's how an interface affects these. So let me show you a bit of the main controlling logic. In Windows, in WinForm applications, there's something called a paint event. Every time an object, every time an application needs to repaint, it triggers this off. And I just want to show you, I might have a whole list of rectangles and images and circles and so forth, but notice I'm not worried about what it is I'm calling. I'm just calling dot draw because they all have a dot draw. So if I call it dot draw and the rectangle knows how to draw itself, it does it. If I call dot draw and the ellipse knows how to draw itself, it just does it. So here I've totally abstracted myself out of knowing what the object is and actually what it does. All I know is I have an object and I need to redraw it. And here's another method I want to show you. So the user has clicked on one of the objects. Let me just go back and show you this. If I click on this, it becomes active. You can see that the little redraw things are shown. So let's say one of these is active and I'm holding it down and I'm moving it. Well, as I move it, I'm getting the mouse X and the mouse Y. Okay. All I'm doing is calling move object. It doesn't know if it's a rectangle or an ellipse or whatever. It just goes ahead and does that and then redraws. It's actually really that, and that's the beauty of this whole interface idea. is that you can abstract the object type and deal with all of them in the very same way. The last thing on this example I want to show you is that I'm using something called the factory pattern. So I'm not sure if I'm going to be able to teach you design patterns in this class. It actually more correctly belongs in an OOP class, a full semester-long OOP class. I'm not sure that though that they cover design patterns here in our OOP classes, but if I can in this class, I'm going to try to go through some design patterns with you. But I'm using something called the factory pattern. And what I have is I have a single create primitive object, and you know, when you click that toolbar to say create maybe another rectangle, normally you'd have to have inline code that says, well, if they click this, create a rectangle or whatever. But instead of doing that, we have this idea that the factory, you can tell it the type, like rectangle, whatever, and it can then go ahead and selectively create the type. So all you have to do is you can embed like a type into this, and then when you click it, you just call this factory pattern, and it doesn't have to need to know how to create that type, and it just returns a new line or a rectangle or ellipse or whatever. So that's taking full advantage of this idea called the factory pattern. And anyway, I wish I had. It would probably take me a couple of weeks to go through all the design patterns with you, not even all of them, and really show you how they work and everything. I just don't have time in this class to do it, but I wish I did. So one thing I wanted to talk to you about is the ternary operators. I end up using these fairly often because it's a really nice way to simplify my code. So let's say int age equals 21. So we wanna, or let's say income. Okay, I'm making this up. Income equals $100,000, and I want to say taxable, or is taxable. I know this isn't the greatest example, but I'm just making it up. Okay, so we have this idea. You could say if income is like above $100,000, is taxable is true. Otherwise is taxable is false. But there's an easier way to do it, because you could do this: if income greater than or equal 100,000 is taxable equals true, else is taxable equals false. Okay, so that works. But notice that now you've chewed up all those lines. Of course, I'm impulsive about the always using braces. You can do it. There's an easier way to do it. You can say is taxable greater than or equal 100,000. Okay, so that sets it up. You put a question mark there. So here's your condition, and here again you can have multiple conditions if you want. You can say that and blah blah blah, whatever. So it doesn't have to even be a single condition, or it can be an aggregate condition. Okay, so if it is true, then you say is taxable equals true, and then otherwise is. I am having trouble spelling today. Is taxable equals false. So that's going to actually simplify your code quite a bit. Actually, this is not correct. I apologize for that. I should have said is, okay, I'm making a bunch of mistakes here. Income, and I'll say is taxable equals. Okay, so that should work just fine. So here's your condition, and here are the two answers. You could also, there's another simpler way. I know this is just an example I made up. You could even say this is income greater than or equal to 100,000. That's even simpler. But that's not a ternary operator. Well, oops. That's not a ternary operator. Well, this is. A lot of times I use ternary operators just when I want to simplify things and not have all those if-else lines. And the last thing I want to do is talk about file I/O. So to do file I/O, you need to add system.io. So we can do something like this. So there are two types of files, straight binary files and text files. So you'll use two different objects. You know, I know in C and C++ you can just use a file object, and whether it's text or binary, it works fine. But you want to use either a stream reader or writer or a file stream object. So the stream reader and writer, that's for text files. The file stream object is for binary files. Although you can actually access text files with a file stream object, but it's not nearly as convenient. So let's say stream reader equals file, and file is from the system I/O, and this is a static method. Create text my info.txt. I do want to mention something about this should be a stream writer. Sorry about that. I want to mention something about backslashes. You can actually do this, C, work. You can actually do that just like you did in the C language. But if you don't want to use those double quotes, you can also put an at outside that, meaning that you're not going to have any escape. You can't. It means that a single slash is not an indicator of an escape code. So that's just a little bit of extra information. Okay, so we'll say writer dot write line hello world. Now, since this is a relative, or I don't have any kind of path information, this will be created in the current directory. And you always want to be a good citizen. Close the file. Now, open files when you quit an application close anyway. But I never trust it. I'm superstitious about a lot of things. So just make sure that if you've created a file, you can go ahead and open it. Or you close it after you've created it, or you open it. Now, to read that file, stream reader equals file open, should be open text info txt. By the way, file names in the Windows world are not case sensitive, so you don't have to worry about that. So I'm going to say string line equals reader read line reader close console write line. So let's go ahead and run this. Okay, so it wrote that out. Now, one of the things you're going to realize is that you might have a text file with a lot of lines. So what you want to do is you want to say while reader.peak greater than 0. If you're reading more than one line, I'm going to put this in here. So obviously that file we created up here only has a single line. So let's go ahead and 2, 3, 4. So now it's going to go through and read all those lines. As long as there's a line available, it'll go ahead and read them all. Okay, so this is a really good way to keep reading. It's kind of like in the C language, that FEOF, file while not FEOF, while not file into file. This is a very similar thing. That's probably all you're going to need to know for this course in File I/O. You can create a binary file, stream, say stream, writer, file, create your info dot bin. So this is what you want if you're going to be dealing with binary data. You want to do that. Here again, it's got a lot of the same things such as close. But this actually will let you save the contents of different variables such as ints, longs, strings, and so forth. So this is a lot more flexible, actually, or it depends on your point of view. But there's a lot more you can do with this. Sometimes it takes a little more effort to get to it. So I'm not going to cover that right now, but I'm going to go ahead and just let you rely on the stream writer and stream reader. Okay, so that's going to cover it for this tutorial. This is the C# OOP lecture, and this is the end of the week, where the second week of no students on UCF's campus. So what we'll do is I'll make sure that there's an assignment at the end of this week that you can do. In fact, these will all be open. You can just run right through them without having to wait for lecture time or anything. And then if we have class next week, then I'll continue with teaching you LINQ, LINQ from the classroom. Otherwise, I'll make a couple more videos to get us through that week also. I'm just not sure what the status of attendance is going to be. So anyway, that's it for this video.